Hello students, in this lesson we are going to talk about integration by part. It is the second method of integration. So integration by part is a special method of integration that is often useful when two functions are multiplied together. This is the formula. The integral u dv is equal to uv minus integral v du. Every time when you will be given integration by part, you will be having product of two different functions. One will be u, another one will be dv. Once you will be given u, you will differentiate it because you need the du to be used here in the second side. And once you will be given dv, you will integrate it because you need v, which is going to be used in this second side. So let's continue and we discuss it. So first of all, we have to discuss the common product that we will meet when we will be dealing with the integration by part. We will have the product of a polynomial and trigonometric function. As you can see, always under integration by part, you will be having the product of two functions. A polynomial can be multiplied together by a trigonometric function. A polynomial can be multiplied together by an exponential function. A trigonometric function can be multiplied by an exponential. A polynomial can be multiplied by a logarithmic function. A trigonometric function can be multiplied with a logarithmic function. Then the inverse trigonometric function and the polynomial. Basically, those are the common product that we will meet under integration by part. So how do we choose u and dv in the other formula of u dv is equal to u v minus integral v du. So pay attention when you are having this formula and you are choosing u and dv. Choose a u that gets simpler when you differentiate it, and dv that does not get any more complicated when you are integrating it. So when you choose u, you will differentiate it because you need du. And when you choose dv, you will integrate it because you need v and you apply the formula. So you will understand this when we will be doing some examples. So a helpful rule of thumb is REACT. Choose u based on which of these letters comes first. So the word REACT, the first letter L stands for logarithmic, A stands for the inverse trigonometric, A stands for algebraic or a polynomial, T stands for trigonometric, and E stands for an exponential function. So here we have some examples. Calculate the following integral: x sin x dx. Let's start with example number 1. We have x sin x. Let's do example number 1. Integration of x cos x dx. As you can see here, I have a product of two functions. We have a product of two functions. So the first one you can see here is a polynomial. We have a polynomial and we have a trigonometric function. So remember, when we are dealing with interpolation by part, we use the word react, and we check which letter comes first in this product. Remember that arrow stands for logarithmic, I, inverse trigonometric, A, algebraic or polynomial T, trigonometric function E, and for an exponential function. In this example, we have x is a polynomial, and we have cos is a trigonometric function. And in the word react, A, which is algebraic, comes before T. And remember, the word in this word react, the letter which comes before will be considered as U. So let U be X, because here I have X. From here I have to differentiate, and I get du will be equal to dx. We have to keep this one. And since T comes after A, it means that we take dv to be equal to cos x dx. If this one is U, the remaining part in this product will be considered as dv from the formula. Remember that the formula is u dv is equal to u v minus v du. This is the formula we use. If one function is u, another one will be dv. So we have our du, which is equal to dx, and dv is equal to cos x dx. Let's apply integral on both sides. It means that integral dv is equal to integral cos x dx. So here the integral of dv is v, the integral of cos is sine. Here, when you are dealing with integration by part and you are looking for dv and you are integrating the dv to get v, there is no need of adding the constant integration. So this is v. So in the formula, remember, the formula states that integral u dv is equal to uv minus integral v du. So I have x cos x dx. I have a u which is x. I'm using this formula. Then v is sin x, minus integral v is sin x. Then du is dx. So we continue. As you can see, I have another integral here which is simple. It is on a trigonometric function. So here you'll be having x times sin x. The interpolation of sin x is negative cos, and there is another sign, so I will have plus cos x plus a constant integration. Then after the integration of x cos x dx is equal to x sin x plus cos x plus c. So this is the final answer for the first question. Another one. Integrate. The integral x ln x dx. So in this example, as you can see, I have a product of a polynomial and a logarithmic function. And in the word react, let's check which letter that comes first. Error, which stands for logarithmic, comes before a, which stands for algebraic or a polynomial function. So which means that u is equal to ln x because error in this one becomes before a. And from here, I differentiate du is equal to du dx is equal to, remember that the derivative of ln x is equal to 1 over x. So du is equal to dx over x. I will keep this one. If one function is being considered as u, another one which is remaining will be taken as dv. So my dv is equal to x dx. Applying integral on both sides, we get x, the integral of x dx. From here, the integral of dv is v, and the integration of x dx is x squared over 2. Yes. Let's continue. V is equal to x squared over 2. So in the formula of integration by part is integral u dv is equal to, or uv minus integral v du. This is the formula that we use for integration by part. So I have u, I have v. So let me replace. So the integral of x ln x dx is equal to u is ln x, v is x squared over 2. So it is x squared over 2 ln x minus integration of v is x squared over 2 du. Remember that our du is equal to dx over x. So we say dx over x. So I have to deal with this integral again. So I will have x squared over 2 times ln x. After simplifying this one will get 1 over 2 integral of x dx, which will be x squared over 2 times ln x minus 1 over 2 then x squared over 2 plus c. So the answer, the integral r is equal to x squared over 2 ln x minus x squared over 4 plus c. Let's do another example. The integration of x e to the power 2x then dx. As you can see here, we have product of two functions. There is a polynomial. We have a product of a polynomial and an exponential function. So the what react algebraic comes before exponential, which means that u will be this polynomial function and u will be this exponential, I mean dv. So let u dx. From here, du is equal to dx. dv is e to the power, dv is e to the power 2x dx. Integrating both sides, we get integral of dv is equal to the integral of e to the power 2x dx. So v, remember that the integral of dv is v. The integral of e to the power 2x is a half. e to the power 2x. So the formula says that u dv is equal to uv minus v du. This is the formula used for integration by part. So I will have the integral of x e to the power 2x dx. I have u, which is x. I have v, which is 1 over 2 e power 2x minus integral. I have v, which is 1 over 2 e power 2x, and du is dx. So this will be x over 2 e power 2x minus 1 over 2 times 1 over 2 e power 2x. So the answer is x over 2 e power 2x minus 1 over 4 e power 2x as a constant of integration. So the answer is the integral of x e power 2x dx. The answer is x over 2 e power 2x minus 1 over 4 e power 2x plus c. So try these questions, evaluate the following integrals. Integral of x e power 7x dx, integral of e power x minus cos x dx, the integral of x squared minus cos x dx, the integral of x power 3 ln x dx.